So we are going to be learning a new type of factoring today. So today is about the factoring. Tomorrow we're going to take these same problems and solve them. Okay? So don't lose these notes and don't lose your worksheet that I'm going to give you because we're going to use it for 2 days. And I'm going to check it for a grade. Okay? So you know ahead of time, got to do it. We have done factoring quite a bit in here, like the chart problems, difference of squares. But there's lots more types. And in this class, we're going to cover 2 more right now. So what this is factoring, and then tomorrow we're solving, like I said. And what these are is the sum or difference of 2 cubes instead of 2 squares, okay? So what you will notice is all of your variables have an exponent of 3. That is a sign that it's one of these problems, and there's 2 terms. You can have a minus or a plus in between, okay? And so there is an acronym we're going to use. It's called SOAP. From here on out, I'm going to call these our SOAP problems. I feel like it's a SOAP problem, okay? And what SOAP stands for is, if you want to write it, same, and I'll explain what this means in a second, opposite, always, plus or positive. Same, opposite, always, plus. Same, opposite, always, plus. Same, opposite, always, plus. I'm going to be annoying when I keep saying it. Okay? So, what does SOAP do for us? SOAP gives us the signs that are going to be in our parentheses. So you're going to hear me when I repeat these things, it's because it's helpful. I say it's a SOAP problem, you're going to do this. You're going to have a small parentheses and a big parentheses. And SOAP stands for same. Okay, same means in this parentheses, you're going to have a binomial. There's going to be 2 terms. You always start with the same sign as the given problem. That's the S. Opposite means opposite of minus. What's the opposite of minus? Plus. That's going to go here. This is going to be a trinomial. It's going to have 3 terms. So there's going to be something there. We're just doing signs now. Then we don't have to worry about what's positive, what's negative. Okay, so same, opposite, and then always plus, that will go here. That one's always plus. Okay, so we'll practice that with 2 more problems in a second. The hardest part is done. Now to fill in the blanks. Okay, we need to know perfect cubes, and you can use your calculator. Remember when we had to find perfect squares and I said it makes sense to make a list of them? If you want to make a list of perfect cubes, it's a smaller list. Okay, so perfect cubes instead of perfect squares is when you multiply the same number 3 times. Like 1 times 1 times 1 is a perfect cube. 2 times 2 times 2 is a perfect cube. 3 times 3 times 3 is a perfect cube. And so on. And we usually don't go any higher than this, although they exist. So the dot, dot, dot that I'm putting here, squeezing in, it keeps going. But when you have this list, you can say the cube root of 27 is 3. The cube root of 125 is 5, the 5th number in this list. Do you have to memorize it? No, you have calculators. Just like I just did 1 times 1 times 1. If you didn't know what 1 times 1 times 1 was, you could put it in your calculator. 2 times 2 times 2, that's the next one. 3 times 3 times 3, okay? So just know how to use your calculator and you're in good shape, okay? So here we go. We start out by filling in these 2 numbers. We're going to do the cube root of 8x to the third. The cube root. So what's the cube root of 8? 2. And the cube root of x to the third is just x. So the first thing that we put in here is 2x. Then we do the cube root of 27. The cube root of 27, 3. Okay. Now, and I don't want you to cross it out, but I'm going to make a point. We're done with this part of the problem. I don't need it anymore. I'm going to fill in all 3 blanks here using these 2 here, starting with 2x. We're going to do something to the 2x, and it's going to go right in that first spot. See how they both are in the first spot? What I'm going to do to the 2x is square it. When I square a 2, I get 4. When I square an x, I get x squared. Look what just happened, guys. If I told you to multiply this, you just had a problem on your test. Oh, I got to talk about your test. You just had a problem on your test like this, where you had to multiply it all out. The first thing you would have done was 2x times 4x squared. That is 8x to the third. Those two should multiply to get that first term. Okay, stay with me. The other number, 3, don't worry about signs. We never talk about signs after we soak it up there. 3, since it's at the back, goes to the back here. I'm going to square 3. That's 9. Quick check, look. -3 times 9 is -27. These two terms should multiply together to get that number. The only one that's left is that middle. And all you do is multiply those two together. So 2, don't worry about signs. Again, it's just the 2x times 3 is 6x. Now that took me a while to explain, but it's really, once you do a few of them and you just keep the pattern going, it's really easy. What we just did was factor. This is the factored form of this polynomial. Tomorrow, we're going to actually solve it. Okay, so keep your notes. Let's do another one. I look at this problem and I say, oh, there's a sum of two numbers. I see that 3. This is a SOAP problem. I do small parentheses, big parentheses. SOAP, same, opposite, always, plus. So same means same. Same. Opposite of plus is minus. So these are always going to be opposite. And this guy here is always plus. What would the cube root of x to the third be? X. There's no number in front. That's fine. Sometimes we don't have numbers and letters. Sometimes we have both. Okay. And the cube root of 64. 1, 2, 3, 4. Right? 4 times 4 times 4 gives me 64. The cube root of 64 goes here. Okay? And remember, now I don't use this anymore. Now I start squaring. I square the x, gives me just x squared, right? X times x squared should equal x to the third. It does. The 4 goes to the back. What's 4 squared? 16. If I multiply 4 times 16, do I get 64? Sure do. Easy to check that you did it right. The one that we mess up on is right here. Everyone kind of forgets that middle one. I don't really have a cutesy way of having you remember, but keep doing these. 4 times x multiplied together. I just take whatever's in there. Don't worry about signs. And I multiply them together. And 4 times x is just 4x. Are we getting it a little bit? Yeah. I squared it. I just take this, whatever this is, and I square it. So it's an x. X squared is just x squared. Same thing here. 4, square it. I got 4 squared. Okay? All right, one more of these, and then I'll show you the second type. Hope you guys are taking good notes. Writing this down. Looks like you guys are. Thank you. All right, I see a plus between two terms. I see that cube. The minute I see that 3, you guys, with 2 terms, I go, it's a SOAP problem. Okay? And I go, small parentheses, big parentheses. And then I do my SOAP. Same, opposite, always, plus. Again, there's only 2 things that can happen here, right? We can either have a minus or a plus. But it's the same process. Same, you have to do the same. Opposite of plus, always plus. And then you never worry about the signs for the rest of the problem. Right? You don't, nothing will ever change. Once you do the SOAP, those are set in stone. Okay, so starting with our first spot, this is our first term. The cube root of 125 is what? 5. 1, 2, 3, 4, 5. And then the x. Cube root of 1. What's the cube root of 1? 1. And by the way, that button on your calculator, if you wanted to do this cube root, would be math 4. So if you hit math and go to number 4, that's your cube root. So if you couldn't remember, you could put math 4, 125. Okay. All right, now, so Mariana, I'm going to square the 5 and the x and put it right here. So that would be 25x squared. And again, a quick check to make sure you did it right is these two numbers should multiply together to get this. And it does. 5 times 25, check it in your calculator, is 125, and x times x squared is x to the third. Same thing with the 1. It goes to the back. If I square a 1, I get a 1. 1 times 1 is 1. Then I just have that oddball guy in the middle. I just multiply 5x and 1 together. Don't worry about signs. 5x times 1 is 5x. That's as factored as you can go. Those are completely factored. It's the same thing over and over again. Do we feel like we're getting those? Yes, we'll practice on a worksheet. There's a second type that you already know how to do, and you don't even realize you know how to do it. Last type we're going to do is a type called grouping. Give you a second to catch up to me while I talk about the test grade. I want to give some kudos. The average in the class was an 85%. You guys did really well on it. Super, super proud of you. 300% in the class. Matthew, awesome. Samantha, nice job. And Marcus, 100%. Tons of A's. Amanda had a 98. Bella, 96. Ashley, 96. Kingston, 96. Richard, 92. Riley, 91. Kirk, 91. Brian, 90. And then there was tons of B's. Very, very high scores. You guys did an excellent job. That was not an easy test. You guys really did take the review seriously. I'm proud of you. You have one more to go this semester. This one. Okay, guys, this looks horrible, right? You're saying I have to factor this polynomial with 1, 2, 3, 4 terms. These are called grouping problems. You'll know to do these because there's always going to be a whole bunch of them, more than 3. I'm going to stick with just 4 of them at a time. But they can get much bigger. And do you remember, and don't write this, okay, because it'll confuse you later. Do you remember like when you'd have a chart problem and then you had to bring down the outside 2 and split the middle? Do you remember that step and we hated it? Well, this type of factoring is, we're already at that step. Pretend that before it, we brought down the outside 2 and split the middle, and you have 4 terms. And you do the 2 and 2. And you do the GCFs and all that. We've already done these. You don't like them, but at least it's only like half of the problem. We factor out whatever they have in common. This is when I would say Chick-fil-A to you. 3 and 2 don't have a common factor except for 1, but they do have x squared in common. Remember, then you divide each of these by x squared. I would get 3x plus 2. This is the reverse of a distributive property. I should be able to distribute the x squared and get what's above it in red. What's the GCF of 15x and 5? It's 5. Yeah. Divide these both by 5. And remember, my parentheses should always be the same. And now we write our factored answer. So 2 parentheses. What's the identical twins can go, it doesn't matter the order. This is multiplication, guys. Let's put our phone down and be paying attention. And the GCFs. I hope this is coming back to you. This is factor. We haven't solved it. Tomorrow we're going to take these factors and solve them. Let's do another one. Again, recognize it. Because think about on a test, they're going to be mixed together with the ones we just did. You have to know which is which. There's 4 of them. Okay, this is my grouping. We factor out whatever they have in common. 2 and 12 have a 2 in common. X to the third, x to the second. They have to be able to give the same amount, so that's going to be x to the second. That leaves us an x there, right? 2x squared times x is 2x to the third minus what? 6, right? 12 divided by 2 is 6, and x squared to cancel. Have to do the same thing to the back. If they have nothing in common, you have to put something. That can be just a 1. They have a 1 in common. But it should make sense because look what's left in the parentheses. Identical twins. That should always happen 100% of the time. Not going to try and trick you and give you ones that won't work like that. Final factored answer. You can put the x minus 6 in any parentheses, doesn't matter. And then the GCFs go in the other. Last one, this one has something that I have to remind you of. Yes? When he comes back. Okay, last one, oops, equals 0. Parentheses, but remember when the third term is negative, you include it, and when we get to it, we have to factor out a negative. So here it's just x squared, right? That's the only thing 3 and 8. 3 and 8 are just 1, and then they have the x squared. So we're left with 3x plus 4. No, plus 8. Sorry. Okay, divided this by x squared, divide this by x squared. That's what's left over. This is what I'm talking about right here. Whenever this third term is negative, your GCF that you pull out has to be negative. Okay? It has to. 9 and 24 have what in common? 3, right? Now remember, I should end up with what I have here. Let that help you. Does it make sense that 3x would go here? Yeah, negative 3 times 3x is negative 9x. But does it make sense that a plus 8 would go here? Yes, negative 3 times 8 is negative 24. Okay, so just don't forget when the third term is negative, you have to make your GCF negative. Final factored answer. Order doesn't matter. You can put them in any place you want. Okay. So today it's just factoring. Okay. So if you look at these, they don't say equals 0 at the end. That means you're just factoring. Okay, so we're just going to factor these. These are your SOAP problems, right? 1 through 4. Small parentheses, big parentheses. Maybe you want to put the perfect cubes on here. 1 times 1 times 1, 2 times 2 times 2, and so on. Yeah. These are the most common ones. But they could go higher. So, SOAP. Same, opposite, always, plus. Same, opposite, always, plus. And if you make this list, guys, you can just count. Like the cube root of 64, that's 1, 2, 3, 4. The fourth number means it's the cube root of it is just 4. And there's no letter. That's okay. They put it at the back. Don't let that bother you. The cube root of 125, 1, 2, 3, 4, 5. And the cube root of x of third is x. Okay? So I did the cube root of that to get that, cube root of that to get that. And now remember, I used the 4 and the 5x to fill in our blank. I don't know why I made this so small. Okay? 4 squared, 16. 5x squared, 25 x squared. Multiply those two together, you get 20x. I'm just mad that I wrote it so small. Let me write it bigger. So I had a minus, had a plus. Square the 4, 16. Square the 5x, 25x squared. Multiply those two together, 20x. That was just kind of messy. Let me do a minus one with you. Now I'll be obnoxious to make it really big. Same. Opposite. These are always opposite. This one's always plus. Cube root of a to the third is just a. And 216, that's one I don't know. I bet it's coming right after 125, but let's make sure. Math 4, and then put 216 in there. Yep, that's the next one. The cube root of 216 is 6. That means 6 times 6 times 6 equals 216. Okay? Square our a. They go together. Square the 6. Goes there. Multiply those together. If you're okay with going out of order, I'm going to do number 5 with you. Immediately, guys, look at the difference in these problems. This has 4 terms. Even though the first term is cubed, this is not the sum or difference of 2 cubes. There's too many things going on here. These SOAP problems should just have 2 things going on, something plus or minus something. This is grouping. GCF. Parentheses are the same. That goes in one set. And then your GCFs. So there's a little bit of work to show here, guys. The amount of work I just showed, minus the hearts. I don't expect you to like the hearts unless you want to. But there's some work to show on these. Okay? So make sure you do. I'm going to put the key up, but it doesn't show this step in between. All right? You have to show it. It could change the answer because of signs. Stay in the order. I know this is a little uncomfortable for us. We want to put the X first because I've been screaming at you, not really, but about the standard form. But I wouldn't mess with it, okay? I would just leave it. Yeah. I actually did show all the work. Okay? But don't copy it. I forgot that I hooked all that. Who is struggling? Call me over to you. I will explain whatever you are having a problem with. I would study that review. Ask for help if there's something you don't understand. Literally now. That is fine.